Okay, we should start. So last time we started discussing astronomy during the time of the Renaissance, rebirth, which marks the beginning of modern astronomy as a scientific discipline. Although even at that time it was still close to astrology, but basically during the Renaissance the two started separating from each other. And as the first person whose contribution I mentioned briefly was Nicolaus Copernicus, who introduced the heliocentric hypothesis that was long time ago first introduced unsuccessfully by Aristarchus, and he said, well, all the planets, including the Earth, revolve along circular orbits around the Sun, with the Sun at the center. The next important name from this period is Tycho Brahe. He was a Dane. His name was Tycho, T-Y-C-H-O, last name Brahe, B-R-A-H-E. He lives from 1546 to 1601. And he's considered to be the greatest naked eye observer in the history of astronomy. King Frederick II built for him on an island an observatory that was completely self-contained, including a little farm, windmill, so on and so forth, print shop. And he spent there 20 years doing the observations. He's famous for taking very accurate positions of planets in the sky. To do that, he used a device called Mural Quadrant, and I'll explain in a second what it is, and I'll show you a picture of an engraving of Brahe with his mural quadrant. This is this quarter of the circle. It was very large, so basically because it's so large, then you could make large markings of equal angles, and as a result you could determine very accurately the altitude of a planet in the night sky. There are his assistants, one who was actually measuring the time when a planet was located at a particular spot in the night sky. Another fellow here making the recordings. And he was a very intense person in more ways than one. Was very hard to work for. Nevertheless, his work was, as you will see later, of monumental value because it basically led to the discovery of the laws of planetary motions. So what he did, he used a Mural Quadrant, and it looked something like this, right? To measure the location of a planet above the horizon with a great accuracy. Now, what he also did, whenever you do a measurement, there is always an error involved, right? If I would give you a ruler of some sort and ask you to measure the length of this desk here, you would put the ruler down and move it a few times and measure the length of the desk. But if you repeat the process, you would get a value that is somewhat different from the one that you obtained before. Maybe because you put a ruler at slightly different initial position than before, right? So these errors in measurements are random. It's the nature of the measurement process that there are always these little things that differ from one measurement to another. And to eliminate these random errors, what is done, even today, is that a measurement is repeated many, many times, and then one calculates the average value over all the measurements. That way, you can minimize the effect of random errors. So that's exactly what he did, and that's why his data on planetary motions is very accurate. So he repeated measurements many times and calculated the average values over all measurements. In order to eliminate random errors. In any measurement process. The only measurement that actually does not, unless you make a mistake that does not involve errors, is simple counting, right? If you have a pendulum that is swinging back and forth, it's easy to count the number of oscillations, right? 1, 2, 3, 4, 5, 10. There is no doubt if you pay attention whether it's 10 or 11 or 9, okay? But in any other measurement involving a continuous set of values, there are always these random errors, and one has to repeat the measurements many times, calculate the average, and that way minimize the effect of random errors. So by doing that, he was able to determine the angles in the sky to 1 minute of a degree. And 1 minute of the degree, which is labeled by apostrophe on top, is by definition 1/60th of a degree. It's a very small angle. Okay, so his data were very accurate. I mentioned before that he was a very intense person. As a young student, he actually had a duel with another student with swords, and in the fight he lost part of his nose. And later on in life, he had to wear an implant that was made out of some alloy of silver and other materials, so he was known as a man with a silver nose. But guess what was the reason for the duel? One would think it was over the girl. No, they were dueling over who was better mathematician. Strange times.